Hi, my name is Manvi, and I'm a high school student from California. Today we're going to be covering another basic algebra topic, and that's all about multiplying and dividing expressions that have exponents in them. So let's get started with that. So the things that you're going to learn in this video is obviously how to multiply and divide exponents, which is exactly what it says in the cover, but also you're going to learn different basic properties of exponents, which are going to be really helpful. That'll actually allow us to solve these problems. Before we get started, the age range for this video is 11 to 13, but it really depends on how comfortable you are with exponents and if you've seen them before. So you should have worked with these before and have a pretty good understanding of the basics of exponents and the vocabulary as well. So if you think that you meet these criteria, go ahead and keep watching. So the first section of the video that we're going to cover is all about multiplying expressions with exponents. So we need to start with the basic rules. So we'll demonstrate these basic rules through a generic example, which is just x to the power of a times x to the power of b. So the first thing that we can do in order to help us understand this basic rule is to expand out the two expressions. So the first expression is x times x times x, a times, and the second expression is x times x times x, b times. It doesn't matter what the actual value of these variables is, we're just using them as an example. So once we remove the parentheses, we can see that we just have a long list of x's, and those are going to be repeated a plus b times, because in the first section there's a factors, and the second there's b factors. So that means that overall this expression is simply equal to x to the power of a plus b. And that's the rule that we need to know. Basically, we need to ensure that we understand that when you're multiplying two exponents, that means that if they have the same base, the product of those expressions is equal to the sum of the exponents themselves. Now you have to remember that this only works if the expressions have the same base. So instead of saying x times a times x to the power of a times x to the power of b, if one of those variables was y, we wouldn't be able to use this rule. This only works if both expressions have the same base as the exponent, and in this case they do. So let's get started with our first example. So over here we have 2 to the power of 5 times 2 to the power of 7. So our base in this expression is 2 and the exponents are 5 and 7. So if we use the rule that we came up with in the previous slide, we can see that the next thing we need to do is rewrite the expression as the expression equals 2 to the power of 5 plus 7. So that's some pretty easy addition, and so our final answer is that this equals 2 to the power of 12. So for the next example, I want you to try solving this on your own. It might look more intimidating with more variables and also more terms, but you have to keep in mind that it's the same concept. So go ahead, pause the video, get a piece of paper, and just try this out. Okay, so I'm assuming that you tried this problem for yourself, and now we can go over it together. So you have to remember that we can only use this rule for things with the same base. So this would have only worked if you split it up like this, where you have a to the power of 2 times 3 times b to the power of 4. We can't combine the b term to the a term because, like I said, they're different bases, and the rule does not apply to that. So if you got this far, good job. If you didn't, it's okay, you'll get there with more practice. And all you have to do from here is some simple addition, and you would get your final answer as a to the power of 5 times b to the power of 4. So now we're going to try some slightly more complex examples where we have 3 of the same 3 terms. So over here we have y to the power of negative 6 times y to the power of 4. All we need to do is just add the exponents because the base is the same. And once you add that all up, you get y to the power of negative 1, which is also equal to 1 divided by y. And you could have left your answer as either one of these and it would have still been correct. So you can try this last example for yourself. It looks challenging, but I'm sure that you guys are going to get this. Okay, so you should have tried this example by now, and we can start to go over it. So just like the previous one that you guys did for yourselves, you have to remember that you can only combine terms that have the same base. So over here, that would have been 4 to the power of 4 plus 3 and 3 to the power of negative 3 plus 6. Once you've done that addition and subtraction, you get the answer as 4 to the power of 7 times 3 to the power of 3. So that's it for multiplying exponents. The next thing that we're going to take a look at is division. And just like we did previously, we're going to just start with the basic rules. So over here, we have a generic expression just like we did for the last example. We have x to the power of a divided by x to the power of b. So we can write it out like this in fraction form so it's easier for us to visualize. So in the numerator, we have x times x times x, a times, and in the denominator, we have x times x times x, b times. So I show this in a fraction format just so it's easier for us to visualize how we can cancel these x terms out because they are all the same base. And it's hard to depict this on slides, but once you've canceled everything out, the only thing that you should be left with is x to the power of a minus b, because there will be a minus b factors remaining. If it doesn't make sense, feel free to diagram this out for yourself, and you should be able to figure out why that's true. So this is our basic division rule. You just subtract the exponents as long as the base is the same. And that's the number one rule we have to remember, that these shortcuts only apply if the base is the same. So we can start with examples again. So our first example is 3 to the power of 8 divided by 3 to the power of 2. Over here we only have one base and it's the same for both terms. So all we have to do is subtract the two exponents, and in the end we will get 3 to the power of 6 as our answer. Over here we have another simple example. So go ahead, pause the video and try this out for yourself. So I'm assuming that you guys tried this for yourself. Again, this is the same base, so all you have to do is subtract the exponents. So you would get 5 to the power of 10 minus 3, and once you've done that subtraction, you'll get 5 to the power of 7 as your final answer. Now we're going to try a more complex example just like we did last time. So we have a to the power of 6 times b to the power of 4 divided by a to the power of 3 times b to the power of 2. Now all we have to remember is that we can subtract the exponents as long as the bases are the same. So we can treat this as two different expressions. So we have a to the power of 6 minus 3 times b to the power of 4 minus 2. And that split is useful because we can then apply the rules to each pair that has the same base. And once you've done that subtraction, you'll just get a to the power of 3 times b to the power of 2. And we can't simplify any further than that, so we can just leave the expression like this. For our last example, you're going to try to simplify 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 7, all divided by 2 times 3 to the power of 4 times 5 to the power of 5. Don't get intimidated by this. It's the same concept that we've been going over for the past 3 examples. So just work your way through it, take your time, and pause the video. Okay, so I'm hoping you got a chance to try this problem out yourself, and if you didn't get it, don't worry about it. We're going over it right now. So what we did in the previous problem was that we grouped each of these by similar bases, and that's exactly what we're going to do this time as well. So what we get is 2 to the power of 3 minus 1 times 3 to the power of 2 minus 4 times 5 to the power of 7 minus 5. Now, if you're wondering where I got the 1 from in the first term, you have to remember that when we don't see an exponent on a number, it's just been raised to the first power. So that second 2 that you see in the expression is just the same as 2 to the power of 1. Now all you have to do is some simple subtraction, and what we're left with is 2 to the power of 2 times 3 to the power of negative 2 times 5 to the power of 2. Now, since these are numbers, we can simplify this expression further, and you would just have to calculate the values of each of the exponents by yourself. So 2 squared and 5 squared are pretty easy to calculate, but if you don't remember that any negative exponent just means that it becomes the reciprocal of the value. If it was a positive exponent, you might have trouble simplifying this one. but you should have gotten 2 squared times 5 squared divided by 3 squared, which would have just been 100 over 9. So thanks for watching. I hope that was helpful. You can contact me if you need more help, and feel free to look up any other resources that might also be helpful for you.